So Lyndon, man, you brought all this stuff back. You brought this inverter. So how did my big question is, how did you solve me cutting right through the water jacket here? How did you fix that?
Yeah, so Kent had a little whoopsies here
with
the Sawzall.
We're having fun converting to electric.
We had to repair it because we have to run, or we're going to run water through this inverter. Yeah, so this is the hose adapter. So I machined out these new adapters.
These look awesome. No, we didn't actually hook water up to this yet to see how it flows out, but you put air on here?
Yeah, so because of course when I was doing this, I had put a plug in here with some protection, and then I was blowing it out. And it definitely does blow out of this, which is the mating side to the other half of the case. Yeah, the case welded up really well. The cast quality of aluminum seems quite good, which is what we would expect. And
yeah, it's like you welded right on there as a test. Where's the other test weld?
Right here.
There it is. Yeah.
So I was sort of testing on the clean surface and then on the actual cast. Because it is so porous, tends to collect impurities, and then when you heat it up, basically they off gas and create a huge mess in your weld. So it would create a super porous weld, which then would be bad because obviously we're trying to seal in water. So I did a test and everything seemed really good. A little more cleaning action on the welder than I would typically do, but that's typical of cast. So then we made up a couple of these. We have one that goes over top of this repaired section, and I drilled and tapped some holes.
And then one of these goes down here, eh?
Yeah, one of those goes down there, and then one of them is a mirror to that other one.
Yeah, it goes to the motor itself. The motor's going to be like over here and the inverter over there.
Yeah.
Yeah, so we got to run hoses for the coolant. So the fan will be blowing through this radiator with lake water in it, nice cold lake water. So there'll be cold air blowing through the heat exchanger coil, and the glycol will be flowing through it. So the glycol coming out of these two fittings here, go round through all the batteries, through the pump, to the back of the boat, around, and then into the charger. Out of the charger, back down underneath, and come back into the bottom fitting of the heat exchanger coil. So the radiator will be bringing lake water out of the pump. It'll flow up into the radiator, come out of the radiator, go into the inverter. It'll come out of the inverter into the front of the motor, which you can't quite see, and then the back of the motor. Back of the motor comes out, and it'll come to the back of the boat and run to the outside.
So, and then our other issue was the three-phase.
Yeah.
So basically we just took, this is all 1/8 inch copper.
Because again, we pulled the motor and inverter away from each other, so now we got to hook the three-phase up.
Yeah.
And we got this channel right there.
On the motor side, these slide into here, and then there's a nice bolt action on the inside, which, and then there must be plugs or something here.
Yeah,
hey?
to seal it up. There
to
is.
seal it up.
And then I just build a cable, bolt it to here, and run that to the motor.
So it only sticks out probably another inch from the case, pretty similar to what's on the motor.
They look perfect.
right, yeah, so our next problem was how do we connect these batteries?
Yeah, because they're sitting inside a battery box.
Yeah. Kent's design has changed a little bit over this course. So first when we built the battery box,
I'm Kent.
when we first built the battery box, we had a certain plan and we were working within certain constraints.
Yeah, we're doing a 144 volt system then.
Yeah.
And we were going to do 6 modules.
Yeah.
Test the modules. And all of a sudden it grew.
Well, and then also our motor and our inverter was going to be stacked and it was going to be longer. So we wanted to have the space.
That's right. We were doing 2 Hyper 9 motors. That's right. End to end.
Yeah.
That's right. So we needed all that room. So the battery box was going to be way up front on the boat. That's right.
And then basically we had to push the batteries out as far as we could to accommodate. We weren't sure, but if that Hyper 9 needed to sit in between the batteries, so we had basically made that gap as big as we could.
And that worked out well because now we're using that cavity for the battery management system, the BMS.
Yeah, and it looks good, but the one thing is the batteries are tight. So you had bought different bus bars, and the biggest issue is getting your hands in there, I think, to connect everything.
Yeah, you can't. Yeah. So it's got to be put one in, bolt it on. Put the next one in, bolt it on.
And the original ones you bought, you couldn't do that because they basically slid over. You had to have a certain
They go
width.
like this, slide over the top.
The magic of an accompaniment tailor-made in the passion, passion, passion of today. Passion, passion of today.
So that was a problem we had
But
to
then we
solve.
came up with this, because we came up with this wonderful idea.
So we're going to
like
bolt
that.
her down there.
And then you're going to give that a twist. So this one will bolt to it.
Yep.
And then this guy will slide. And then when you slide that over, this guy comes up.
We'll put it on
Bolts
the
onto
next
that one.
one. This will have the same sort of angle twist, which I've sort of twist this copper and it twists pretty easy. So
Yeah, so it'll be like that.
we'll be able to fit it pretty nicely,
It'll be
I
like
think.
that.
It's going to be tight and the batteries will have to be put in, everything sort of assembled, and then the next one. But so we had to make 8 of those. It's all 8-inch copper by 1 inch. was our latest set of problems that we sort of worked through, and on to the next ones.
Electric, zero emission vehicle, go green.